Hello everyone. Today's lesson is on alkanes, which are the simplest form of organic molecule. So, to understand what an alkane is, we need a couple definitions of some terms we're going to be using. The first one is saturated versus unsaturated. We've heard about these words before. We've used them in our normal conversations. Saturated means it contains as much of a substance as possible, right? If we have a solution or a cup of water that's fully saturated with salt, that means we can't dissolve any more salt into it. In terms of organic chemistry, what saturated means is that it contains as many hydrogens as it possibly can, meaning that all of our carbon bonds here in our carbon backbone are single bonds. So here, right, we have a 4-carbon backbone. They are all single carbon-carbon bonds, meaning that all the other bonds are completely filled with hydrogen. We can't have any more hydrogen than we have here without adding more carbons to it. Unsaturated means that we have, at some point in our molecule, some double or triple bonds between the carbons, like you see here. And because of that, because now between these two carbons we have 2 bonds occurring, you'll see that on each of these carbons we only have 1 hydrogen instead of 2. So an unsaturated molecule has fewer hydrogens. And if you've ever heard of saturated versus unsaturated fats, that's exactly what it's talking about, is whether we have these single hydrogens here, or single bonds between the carbons, which allow for more hydrogens, versus double and triple bonds kinked in there, which changes how the molecule interacts in our body. So, an alkane is the simplest form of organic compound, and it is any saturated hydrocarbon chain. So alkanes are saturated hydrocarbons, meaning they only have single bonds between the carbons. So the prefix, all alkanes have 2 parts to their names. They have the prefix, which goes in the beginning, which tells us how many carbons are in the chain, and then the suffix ane, which tells us that it's an alkane, meaning it's only single bonds between those carbons. So for now, until next lesson, they're all going to end with ane as the ending, because we're only going to be dealing with single bonds or fully saturated hydrocarbons here. So our prefixes, though, some will be familiar, some will be new. Our prefixes are here. 1 through 4 are going to be new, ones we haven't seen before. 1 is meth, so a 1-carbon, completely saturated organic molecule would be methane. We've heard about that before. Ethane means there's 2 carbons. Propane, prop means 3. We've all used propane before. That's a 3-carbon chain. Butane is a 4-carbon chain. And then once you get to 5, then it just goes back to our Greek prefixes that we've used before, right? Pent means 5, hex means 6. So we have pentane, hexane, heptane, octane, nonane, and decane, going from 5 to 10 here. So again, the prefix, the beginning part, tells us how many carbons are in that chain, and then the ane at the end tells us that it's only single bonds between those carbons. So here's a nice chart. It gives you the number of carbons, 1 through 8, the name, methane, ethane, propane, etc. And then it gives you the Lewis structure, right? So methane, 1 carbon, means we only have 1 carbon. And then remember, carbons have 4 bonds to them, always or almost always. So if it only has 1 carbon, it's going to have 4 hydrogens around it here. Ethane has 2, meaning we have 2 carbons with a single bond, and then the other 3 bonds on these carbons are going to be full of hydrogens. Propane, we have 3, and then we fill the other bonds with hydrogen, so on and so forth, right? So we are going to practice writing the molecular formula and the Lewis structure for the following alkanes. So we're going to write it for ethane, we're going to write it for pentane, and octane. But before I do that, I want to go back and emphasize this right here. Forgot to talk about this, but we have a sort of formula that allows us to quickly know how many hydrogens there are, depending on how many carbons we have for any alkane here. So this N is the number of carbons that you have. So for example, if we did propane, right? Propane has 3 carbons. So our formula for propane, you could either draw it all out like we're going to do, or if you just need the formula, you know that we have 3 carbons, so N would be 3 in this case. So we'd write C3, and then the number of hydrogens is going to be 2 times however many carbons we have. So in this case, 2 times 3 is 6, plus 2 more. So 6 plus 2 gives us 8. So the molecular formula for propane would be C3H8, and any and all alkanes will follow this formula here. So for example, decane is 10, right? We would have C10H, 2 times 10 is 20, plus 2 is 22. So H22. So C10H22 would be our formula for decane. And using this formula here, we can figure it out without having to draw it out, which will save us some time. So we are going to write out the molecular formula and the Lewis structure for these 3 alkanes here. And I pre-recorded myself doing these, so we'll watch the short videos and we'll talk about what's going on. So here is ethane. So again, first thing we need to do, we're going to look at the prefix. Eth means 2, right? So we know we have 2 carbons. And ane means it's an alkane, so it's all single bonds together. Ethane's a nice small molecule, so it's pretty simple. The first thing I do is I draw out the carbon backbone, which since we only have 2 of them, would be C-C. If we want to draw out the molecular formula, which it does ask you to do, we can plug into this equation here, right? The one I just showed you, where C equals 2, because we have 2 carbons, and then 2 times 2 plus 2 more gives us 6. So C2H6 is our formula. So then if we write out the carbon backbone, we get the 2 carbons there. And then we just completely fill them with hydrogens like we see here, right? So now we have our 2 carbons connected with a single bond. Then we fill up the other bonding sites, all the other bonding sites with hydrogens. And if you count to double check, we have 2 carbons, C2, and then 1, 2, 3, 4, 5, 6 hydrogens. It works out, right? And all of our carbons have 4 bonds, so we're good to go. So this would be ethane. Our formula would be C2H6, and our Lewis structure would look like this. Pentane, same process, right? First thing we're going to do is look at our prefix. Pent, hopefully remember, means 5, like a pentagon. So we know we're going to have a carbon backbone with 5 carbons. The ane ending tells us that they're all just going to be single bonds. So we can make our carbon backbone like we see here, with 5 carbons all single bonded together. If we want to, again, figure out the molecular formula for it, we can follow the exact same equation where our N value, the number of carbons, is going to be 5. So we'd write C5, and then H would be 2 times 5, which is 10, plus 2 more is 12. So we would have 12 hydrogens there. Then we just fill up our carbon backbone until it's fully saturated with hydrogens, meaning that each carbon has all 4 bonding spots taken up, right? You'll notice that all the carbons on the end, the 2 carbons on the end, have 3 hydrogens, and all the ones in the middle have 2. But you'll notice if you look at each individual carbon, each one has 4 bonds, right? They're following that octet rule. Each bond is 2 electrons, and they want those full 8 electrons like we spent so much time on earlier in the year. So pentane would look like this. We have 5 carbons. It's fully saturated. We have single bonds between each carbon, and we have 12 hydrogens filling up all of the extra bonding sites for each carbon. Last one is octane. Oct, like an octopus, means 8, right? So we know that we have 8 carbons in this molecule. If we again want to write the formula, we can, or want to write the molecular formula, we can use a little alkane formula there. and carbon is 8. We have 8 of them. So 2 times 8 is 16, plus 2 more gives us 18 hydrogens. So C8H18 would be our final molecular formula. Then we have to draw out our carbon backbone. Make sure you count 8 correctly. Then we just start filling in all the empty bonding sites with hydrogens. Again, I can't emphasize this enough. All carbons need to have 4 bonds, right? Whether they're between carbons or between carbon and hydrogen, depends on the situation, but they'll always have 4 bonds for each carbon. So that would be octane, right? We have 1, 2, 3, 4, 5, 6, 7, 8 of our carbons, making our octane backbone here. And then we fill up all of the empty bonding sites with hydrogens to make it a fully saturated molecule, making it an alkane, right? That's why it's octane. You'll see later on, we're going to have different endings that tell us different things. But for now, ane means we have only single bonds between our carbons.